Hi everyone, can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay, cool. Super. So Summer, I've also made you the co-host, which means you can admit people as they request because at least 2 or 3 people sent me an email that they have a class just before this class and it's hard for them to join 5 minutes before the session. So at least we know
Okay.
that some students have classes, so they might be coming in like just around 6 or so. So I think we can accept that for those students who requested it. But as far as admitting people early is concerned, I've been told, and I stand corrected now, that I cannot force you to come early. So while I encourage you to come early and learn, and kind of get ready, prepare yourself for the actual session, I cannot force you to come. So when I said that it's compulsory, maybe I shouldn't have used that word, so I stand corrected now. And I will just say that for future sessions, I would encourage you to join earlier. And with this, I just wanted to start the discussion. So, oh yeah, so basically, two things that I noticed in the last session, some people were coming 10, 15 minutes after the session had started. I think 2, 3, 4, 5 minutes is understandable, but 10 minutes is, I think, unacceptable as a student because, and unless you've given me a reason, which none of you ever give me a reason for not being in the class, for not doing anything. It's only when I ask or only when I inquire why there was lesser attendance do people actually reply to my email and say, this is the reason why we weren't in the class, or this is the reason why we couldn't do what you told us to do. So just a clarification on that. And then when I sent the email, when I sent the message, maybe I wasn't in the right space. So I was trying to be stricter, but I can still try to be kinder. But just understand that in the upcoming classes, we could have quizzes both announced and unannounced. And maybe we will have, like, I have to decide where to take a Viva, whether it should be 50% of the mid or whether it should be some of the quizzes, because they would need a lot of time. We were over 40 students. And whenever I decide to take that, I have to think well before deciding exactly what to do with the Viva and how to run it. But that's something that Summer and I need to discuss. I think that most of you are here. Do you guys have any questions? If not, maybe I can just start with the home task that I gave you for last week. Hassan, you have a question?
Yeah, ma'am. Assalamu alaikum.
Assalamualaikum.
Ma'am, I wanted to ask that the task that you usually give right after the session. So, is that task counted towards our written CP or is it something else? Because I twicely checked LMS and there was no any sort of notification in the assignment bar in the name of written CP3 or any sort. So I thought that it is not given from your side. So please clarify on this. And
It's
secondly,
just class
yeah.
CP. It's class CP, and what I wanted to, because I saw in the chat box, so once the class is over, I try to read as many chats as possible, and I saw that most of you were engaging or having a discussion around
Yeah.
the drinking water, and then that's when I decided that maybe I should give you a question relating to the drinking water, because I once spoke with someone on this floor who told me that they have never changed their filter, at least as long as she could remember. And you know that that kit that comes has a life, the filter has a life, and then if there is UV disinfection, that has a life. So I just wanted to see where do you stand, and or if you buy bottled water or if you boil water, then you should know what you're drinking, and you should know how certain filters need to be changed, and to know exactly what kind of filter it is. Of course, if you have the documents that came with it, I thought you would know if you have any high filtration cleaning filter in your house for the water, or is it something else? So it was just for you to be more open about anything that is around you.
Yeah, ma'am, I got that, but I just wanted to ask that whether we should email these kind of assignments to you, or we should, or what sort of do we need to present them in the class?
No, I just wanted to discuss
So
it in the class. But if all the discussion that we're having is on what did we need to do, I mean, it's just for you to understand your surrounding better, and it's just for you to be more inquisitive about what's around you and what you're drinking. So I think it was more than just submitting it as an assignment. It was more like understanding what you're drinking and understanding the process of filtration and cleaning of water that you drink in your house.
okay, thank you.
All right. So if no one else has any comment, maybe I can just start with the presentation.
Dr. Fawzia Taha has his hand up.
Yes, Taha.
Yeah, ma'am, I just want to ask that since I don't have a science background, I just want to ask that you mentioned about the Viva. Exactly what will that have or what will that contain for us to do?
If there is a Viva for mid, then it would of course be around the course that I've given you, the text, the presentation, and also some of the class participation questions could come in as well, or some of the things that I ask you to search. So for example, I may not ask you about anything that I teach you today, but there is a part where I ask you to just read about what urban heat island is. So maybe I'll just ask you, or did you go through the urban heat island? What did you think? Do you think Lahore has become a urban heat island? And how do you think can we change it? And those kinds of things. But there's no strict, but if I decide for a Viva, then I'll tell you exactly what would be included in the Viva and how many sections. So most probably that would be the course until your mid. And don't worry, like I keep telling you this, but I would say it once again, don't worry about knowing every scientific term here. Of course, those who have science background should know that and more. But those of you who've just come in and are learning, it will take you time, for you to read multiple documents and for you to read this multiple time and use this multiple time. It is going to take time. And I will establish that when I engage with you on any medium. All right, so today we will be discussing the atmosphere, and all of this, these spheres and everything else was actually for us to eventually be able to study the biogeochemical cycles or the nutrient cycles of how nutrients are being recycled into the earth. And we looked at the biosphere, we looked at the hydrosphere. Today we'll be looking at the atmosphere. And as I said, all these spheres of the environment, they are interconnected with each other and they are interdependent upon each other. And just the basic discussions and what the atmosphere is, how energy flows here, what kind of pollutants exist in the environment. And towards the end, I'll give you another home task, which would be to understand your weather report. And I think in the past fewer presentations, when I mentioned energy flow, I did not mention information flow to an extent that I should have. So today I've dedicated a slide for it, which is because everything that I mentioned in the biosphere and the hydrosphere, I mostly refer to the energy and matter flow in these spheres. And information flow is an important component of all kinds of flows that happen between the spheres. And by information flow, I mean the information that is carried by each genes. And those genes express the trait that we have as human, from hair to eye color to many other features, as well as the record that is kept in the, let's say, fossil records. So if we are taking the ice from a glacier at a certain depth and looking at the air bubbles inside and finding out the methane concentration or the nitrogen concentration or many other things that are important for climate change, it essentially has accumulated a lot of wealth of knowledge or information, which is also changing with time, which is also evolving with time, which is also because of, for example, in these genes, if the environment changes, if there are genetic mutations, then many things change in how they express themselves in an individual as well. So I just want to establish the fact that in these 4 environmental spheres, not only is there flow of energy, not only is there flow of material, but there's also flow of information. And before we speak about atmosphere, I think the most important concept for us, basic scientific concept for us to know would be energy. And energy can be, it's basically the capacity to do work, or it is the capacity to transfer heat. And it could be as simple as just carrying something and putting it elsewhere. So a force is involved, distance is involved, or simply touching another object where you're conducting a certain amount of heat from, let's say, a warmer body to a colder body. That's essentially energy. But in the environmental sciences, energy, especially stored energy and kinetic energy, are often referred to as energy that is used in wind, or the solar energy being harnessed for solar light, or the turbines, the ocean tides, etc., for generating electricity. So that energy which moves is referred to as kinetic energy, and the energy which is stored, let's say the dams that we discussed last time, the energy that's stored in there, which then turns into kinetic energy and moves and hits a turbine and turns it into electricity, which is another form of energy. It basically transforms from the stored energy or the potential energy to a kinetic energy. And generally in atmosphere, and whenever we try and understand atmosphere and air, this is the kind of discussions that we will have. How's heat transferred, how are certain waves or radiations reached, absorbed, emitted, etc. That's the kind of language that you use when you discuss the air. And of most importance in the context of air atmosphere would be the electromagnetic radiations. And maybe this would be a little simple for those who've studied physics, but they can just consider it as a refresher of their first semester. So it's basically the radiation that's coming from the sun and it's reaching Earth. And it contains many kinds of radiations, many waves, and only some of it is able to reach Earth, and only some of it is absorbed by Earth, and some of it is radiated back to the atmosphere. And if you could just divide that whole influx of energy or electromagnetic radiation, it's divided. So the most relevant to us is this visible range, right? Which is the world that we see in the visible light. So when you see a plant, you see it as a green color plant, not just because of chlorophyll, but because of the fact that chlorophyll is able to absorb every other color in this and only reflects green. And that's why you see the plant in green color. And that is the ability of the chlorophyll. And similarly, any other color that you see follows the same principle as well, that from the visible light, which is around 400 to 700 nanometer, it would absorb a certain range, and then it would emit a certain range, and that emission or wavelength of that emission would decide what color the object is. And you can look at all of this, but basically there are shorter wavelength, higher frequency, higher energy radiations from the sun, and there are longer wavelength, lower frequency, lower energy radiations from the sun as well. And if you just focus again more on the visible range, it would basically, it's showing the same thing, but with different scales of how both the frequency, which is cycles per second, as well as wavelength, which is the distance between the crests of the wave that you're seeing, how that is increasing as you move from the radio waves to the gamma rays, for example. And in the visible range, you would see that it's just followed by ultraviolet radiations on one side and infrared on the other. And you would often see these two being discussed in climate or atmospheric sciences very often. IR is discussed a lot, and UV is of course discussed a lot because of stratosphere and greenhouse gases, etc. And the reason why I wanted you to see that before we come to this slide is because you will see that visible light is coming in. Some of it is already reflected in before it enters the troposphere, and some of it comes to the Earth and then is reflected, and other is absorbed and is then emitted. And infrared radiations come and hit the surface, and then they are emitted back into the atmosphere as well. And in all of that process, it basically maintains the temperature of the Earth. So we often read when we were young that the Earth absorbs all the sunlight during the day, and then at night it releases it, because at night the temperature is maintained, etc. And then without this blanket, we would freeze at night and we would boil in the day, and all those kinds of discussions. But because I think greenhouse effect is something that you study throughout, whether you're a scientist or a social scientist, I think I wanted to just send this question to you and see if any one of you would want to explain what they think climate change is. And please raise your hands if you want to tell me. And I'm specifically looking towards people in physics, chemistry, etc., but also people from the social sciences. What is greenhouse gas effect? Or what is greenhouse effect? Yes, Hassan.
So, as far as I can break it down, it's basically the accumulation of molecules, basically particles in the air that contribute to storing heat. Like you can see infrared radiation being reflected back out of the atmosphere. But these gases allow for them to remain in the atmosphere. They absorb that heat and then re-emit it back onto the Earth's surface. So they don't allow this heat to be released back into space.
Yeah.
And that contributes to the heat increase.
I can take one more person, and then maybe I just go ahead with Manal. Do you want to talk?
So the greenhouse effect is basically the ozone layer is supposed to absorb all the UV radiation, but because the ozone layer is depleting, that UV radiation is not being absorbed and it remains in the atmosphere. So this causes heating to take place, and this heating then causes the melting of glaciers, and that's basically what climate change is.
Yeah, exactly. So basically, there are greenhouses around. So greenhouse generally is a plastic cover or any other material that we put so that our plant, especially in winter, so that our plant could have more warmth for it to grow. And that plastic material allows for heat to come in and traps it for a longer amount of time, and that's why the plant is able to grow. A similar kind of blanket is formed around the Earth with the help of gases that we call greenhouse gases, which act as a blanket to the planet. And in a certain amount, they have, for example, ozone has protected us from the UV radiations, but gases like carbon dioxide, gases like methane, they have the ability to absorb more heat. And when their concentration in the atmosphere increases because of our human sources, then they trap more heat, and that's why Earth is warming at a faster pace. And that is exactly why we call it the greenhouse effect. So you're all correct. Thank you for chipping in. And what is atmosphere or air in general? It's a mixture of gases with numerous suspended particles, both solid and liquid. But I've shown an extended table in the annex slides. Here, I just wanted you to see that nitrogen and oxygen dominated, and the remaining 1% is a lot of trace gases plus argon and carbon dioxide. So 78% of it is nitrogen, 21% of all the gases in the atmosphere, and I'm referring to the dry gas or the dry air in the first 25 kilometers of the Earth, not the water vapors. This is the composition, and this composition's been agreed on and taught for ages to people. So essentially, air is mostly nitrogen, oxygen, and 1% of many other gases that remain in the atmosphere. And most of this weight lies in the very top surface, or the surface that is close to the surface of Earth, or the troposphere, which we will see in the slide that we're looking at now, what it is and what we're talking about. So after the Earth's surface, there are several spheres of the atmosphere. We would mostly be concerned with the troposphere and the stratosphere. So stratosphere is where the ozone layer is. And that's why it's also called the ozone region. But the troposphere is the sphere around us. The air that we live in is basically troposphere, and it goes up to almost 17 kilometers above us. And then up until 50, 55 kilometers is the stratosphere, and mostly that's where we lie. And the image that I chose from the internet, it shows you the scale of things, right? Of where our aeroplanes are flying, where are clouds stationed in the sphere, and how tall is Mount Everest compared to this. What you'll also see in one of the bars is how temperature changes as you go from one sphere to the other. And you'll see that in troposphere, as you go up, the temperature decreases. And then in the stratosphere, increases again. And it increases because of the fact that a lot of warm gases or gases that could trap heat lie in the stratosphere. And also because the weight is higher here. And in the stratosphere also, I think the one thing that I want you to remember as we move ahead, before we move ahead, is the fact that oxygen in the stratosphere reacts with ultraviolet radiations and forms ozone. And that's why presence of ozone is very important, because higher the ozone, more ultraviolet radiations would be trapped there. And they will not allow for the ultraviolet radiations to come down to the troposphere because it damages, and it's not good for our skin or plant production or growth, etc. Hassan, do you have a question?
Actually, I was typing. So, ma'am, I wanted to ask that smoke season is about weeks time from now. So, what a portion of nitrogen, carbon, and other gases can we find in its content? Like, what is that made up of? Yeah.
That's a good question. And we are actually going to study a lot of air pollutants today in the coming slides. And it will tell you that it's not one thing or the other, that it could be one thing, but it could also be a combination of all of those. And because we do not assess or analyze our smog here, very often we don't know what it is. We just know the size of it. We just know that there is smog and that it is coming from a certain source. But the composition of it, we are very unaware of. And you will see this as we go through the slides, the coming slides on air pollutants in the air. So basically what happened was that NASA started observing these, we understand, again, the natural capital or the ecological service. I think ozone or the oxygen in the stratosphere is doing us that service by protecting us from UV lights. And that ecological service, when it was understood that skin cancer was increasing, that the ozone was actually thinning because of activities on the surface of Earth, they started observing it in the 1959 onwards. And in 1985, they observed the thinning of ozone, which is the image of the globe that you see. This image is from 2017, it's colored, but it basically tells you that above Antarctica, the ozone is thinning, and this is also called ozone hole. And because most of our ice caps lie there, we scientists particularly felt threatened by the fact that the ozone has a hole or has thinned over that area. And it was said, and I think it still is, because of a lot of chemicals that we use in our air conditioning, our refrigerator as coolants. It's called chlorofluorocarbons. And then, a transition took place, and people said that because chlorine is more dangerous, and then they switched. So now I think instead of chlorofluorocarbons, they're using hydrofluorocarbons or hydrochlorofluorocarbons, which they think are less dangerous than CFCs. But I don't think an absolute replacement has come. And even if there are replacements, if you switch it, sometimes you have to switch it with CO2 in a particular process. And even that is a greenhouse gas. But because CFC directly attacks the ozone, the preferable thing would be to make sure that we replace it with something else. But I think already people are switching their ways, and technology is transferring that way as well. And the other graph is exactly what we discussed in the previous slides, that the planet is warming at a faster rate. And it is warming because of the fact that we're allowing more warmth to come from outside of the planet, from the solar light onto us, as well as we're producing more heat here. And together they're making the planet much warmer, and this trend is also only increasing. And like I said, in the annex you would find a detail of all the gases that are present in the air. It's just for you to know. You don't have to cram each and everything, but the most essential ones and those that are essential to life, their environmental role is either important in the chemical processes in the atmosphere, or they're important to life, like carbon is essential to life because all life is based on carbon. But something that I wanted to establish before we leave or go ahead is that ozone is very helpful in the stratosphere, but it's on the troposphere, it's a pollutant, it's a toxic chemical. And because it's highly reactive, we consider it an environmental pollutant on the troposphere. And in the stratosphere, we consider it a good ozone, maybe. And I'm not putting other pollutants here because we will be studying them in the upcoming slides. And in the previous slide, I think I mentioned that the composition of the dry air. So that's because water or water vapor is another major component in the air. And it also acts as a greenhouse gas, as a vapor, or it also acts as a greenhouse gas. So that's why sometimes they're taken completely separately. And when they give the composition of the atmosphere, it's mostly as dry air and not as wet air. So air pollution can be both. Don't think that we are the only ones who are ruining the environment. Naturally, air pollution has happened. The dust that we see, the wildfires that happen, they also decrease the visibility. They also increase smoke. The volcanic eruptions also have a soot of their own. It also contains sulfur and many other environmental toxicants. And similarly, volatile organic compounds that are released by plants, because plants need to defend themselves against many attacks from pests or even environmental pollutants. So they sometimes release volatile organic compounds. And those compounds are also natural sources of pollutants. But industrialization, especially urban industrialization, releases it at a rate that the nature cannot take care of. So the cycles that we'll look at later in the upcoming lecture, basically that cycle is being disturbed because one reservoir has increased. So a reservoir of carbon has increased at one place, and that's why the entire process is changing. Yes, Fateh?
Yes, so can you hear me? Uh, yes, so I just want to add to it. You were like ranching, raising cattle and all. There they say that they are also really pollutant. They cause air pollution in the sense that cows, when they excrete, they release methane gas, and methane is harmful to the ozone layer or something.
Yeah, so methane is also a greenhouse gas. And yes, that's another natural process of emission of a greenhouse gas into the environment. And that's why oftentimes you would see the environmentalists fighting against farming, saying you can't farm these animals at a very wide scale because that increases the concentration of greenhouse gases. And I think in some of the slides that I've added later, I've also shown that how even your solid waste management could contribute towards greenhouse gas emission. Nadia.
Ma'am, I have a question from the previous slide.
Go ahead.
Ma'am, I wanted to ask about the hole in the that was created over the Antarctica in the ozone layer. Ma'am, there are no direct human activities that can pollute. I mean, they can directly affect the ozone in the Antarctica, right? But there are other areas on the Earth where we are directly sending gases to the ozone that can deplete them. Then why was the first hole observed in the over the Antarctica?
I think, yeah, that's a great question. Basically, I think this was the first time people woke up. So similar to the ozone hole, or let's say the ozone degrading because of the gases that we were sending into the atmosphere, microplastics have been detected in the Antarctic ice. and there's no life there, except for maybe a few researchers. There's literally nobody there. And it just goes on to show that the source of a pollution has become less important because of the way wind travels, and that again has to do with the atmosphere. So maybe in the form of, if it's very light, it can travel with the clouds. If it's a particular pollutant, if the wind can carry it, it can go there. But the basic establishment out of these researchers was the fact that it is not important, and I think we'll see in some of the future slides as well, of where the pollution is produced. Don't think that if there are factories in Lahore, it will not impact the air of Hunza. It can totally impact the air of Hunza because air travels in a certain way, and that it would carry the pollutant up to a certain distance. And it totally depends on the nature of the pollutant. So, and also sometimes in the atmosphere, there are reactions that are triggered, right? So for example, if a chlorofluorocarbon molecule went into the atmosphere and it kicked out the oxygen out of the ozone, and then it traveled to another molecule, because then it allows it to be recombined, right? So they're both very reactive. So maybe it just moved from one ozone molecule to another, to another, to another, unless it could go that far. But I think from these researchers, the basic establishment was exactly what you've asked, and that's the fact that you could be living in the most pristine environment, but something somewhere else might affect you. And this also, for example, came into picture when acid rains happened across the globe. Some of the acid rain happened in areas which were absolutely pristine, and life was damaged. All right. So
Yes, ma'am.
okay, super. So we will just look at the pollution, and then so again, another important thing which is connected to the question is primary pollutants and secondary pollutants. Primary pollutants are chemicals that we release into the atmosphere. Like we released carbon dioxide into the atmosphere, we released sulfur dioxide into the atmosphere, or we simply released, let's say, smoke into the atmosphere. And secondary pollutant is when the primary pollutant combines with something and becomes something else. It could be more dangerous. So when smoke combined with fog or many other things into the atmosphere, I think smoke became more dangerous because it had now combined with fog to be able to change not only the visibility, but also the human health. Let me admit Farouk. And so that's, those are the kinds of things. And also with reference to pollution, it can be mobile, it can be stationary. So the aeroplane that's traveling over Antarctica could be one reason why the ozone layer there was disturbed, amongst many other reasons. But let's say if there was a lot of traveling happening above Antarctica, or if, a certain kind of mission was being sent, maybe that contributed towards it as well. So it depends on how we look at it. And I quickly wanted to introduce you to some of these pollutants, because the same elements will be important for us in the cycles that we look at as well, because some of them have increased due to human intervention, or what we say anthropogenic activities. And some of such pollutants are carbon oxides. One is carbon monoxide, so carbon with a single oxygen, and the other is carbon dioxide, which is carbon with two oxygens. Carbon monoxide is colorless, odorless. If you are where I'm from, for example, from the north, if you burn the wood, and if there's incomplete burning, if you're using a vehicle and there's in the exhaust, or if the fuel doesn't burn properly, you could release carbon monoxide instead of carbon dioxide into the air. And similarly, if you're burning vegetation, if there are wildfires, they could also contribute to carbon monoxide, as well as tobacco. I think tobacco, although a cigarette is so small, but I think the kind of environmental pollutants that it can release, it's just an example of how damaging a certain kind of pollutant can be. And similarly, inefficient stoves, open fires, etc. And they are bad for your health because they combine with the hemoglobin, and the oxygen transfer in the body is impacted. And that's why you get heart attacks or lung diseases and and it can cause nausea and sometimes coma and instant death, depending on how high the concentration of carbon monoxide in the atmosphere that you're living in is, especially if it's a closed environment, right? Especially if it's inside the house, or if you are in a forest that is on fire and there's a lot of carbon monoxide in there. Now, carbon dioxide is, we all established that it's a greenhouse gas. It can absorb heat. And most of the study on greenhouse gas often takes place with CO2 in the center of it. And this is a NOAA graph, which was published in March this year, that shows that throughout these observations that started in 1959 up until now, the concentration of CO2 at this particular observatory has only been increasing at an exponential rate. And some people might say that carbon dioxide exists in the environment naturally. Yes, most of it does exist in the environment naturally. But the anthropogenic sources, which is the fossil fuels, the way we are damaging the environment. So for example, if we cut the forests, then they are a sink for the carbon dioxide because they take carbon dioxide in. Or similarly, if the oceans are polluted or covered, sometimes the oceans serve as a sink for carbon dioxide as well. When we damage those natural capitals, or when we degrade them, then there is higher concentration of carbon dioxide in the atmosphere. And even that small increment can impact the warmth or the warming of this planet. And you will see that how if in terms of parts per million, how it has increased from 310, 20 to now approximately 400, which is, I think, a high number, something that we should be alarmed of. Now, we studied about carbon oxides, which included carbon monoxide and carbon dioxide. Now we will look at nitrogen oxides, as well as nitric acid. And they are called NOx, so NO with an X. So sometimes when people talk about pollutants, they generally just refer to them as NOxes. So nitric oxide is one of them, nitrogen dioxide is one of them, dinitrogen oxide is one of them, or nitrous oxide, and then nitric acid that can be formed. And this will also be a little complicated for those who haven't studied science in a while, but we'll also be studying it in the nitrogen cycle. So just for you to know that nitric oxide, so for example, nitrous oxide comes from fertilizers, it comes from greenhouse gases, it comes from animal wastes, not just methane, but this N2O also is emitted from natural sources as well as from burning of fossil fuels. Nitric oxide and nitrogen dioxide, some of them are already present in the environment, some of them are released, so they're present naturally, as well as produced by, let's say, automobile engines or power plants that run on coal, or industries that run on coal. And they are, and I think because all of you have interest in smog, from the first lecture till now, you've mentioned it oftentimes, all of these pollutants are related to smog because these nitrogen oxide or nitric oxide and nitrogen dioxide, they both cause photochemical smog. And I'll explain photochemical smog to you in the coming slides. And they also irritate, they do kind of the same things that smog did to us. They're irritants, they aggravate lung ailments, they aggravate heart ailments, they reduce plant growth, and then they reduce visibility, especially in the form of nitric acid and nitrate salts. So that combination of nitrogen and oxygen, when it goes into the atmosphere, when it combines with water, it can form nitric acid, which is soluble in water. And that acid can come down as rain. And it has been a recurring phenomenon in many places, and it's referred to as acid rain. So they are together called NOxes. And similar to NOxes, there's also a category called SOxes, which is oxides of sulfur. And just like nitric oxide, sulfur dioxide can also produce sulfuric acid, which also leads to acid rain. And similarly, similar to other gases, it occurs naturally, and the other forms or the human sources of it are mostly burning of coal plants or oil refining. So for a lot of these, especially if you go abroad, you would see on buses saying that these buses are SOx and NOx free, or they are because they basically knock the sulfur and the nitrogen out of their fuel, and their fuels are really clean, which means that when combustion happens in the engine or in the power plants, they will not release sulfur dioxide or carbon dioxide or nitrogen dioxide into the atmosphere. But also the natural process of taking sulfur out, or the smelting of sulfur ore, is also something that can produce these air pollutants. And they can be converted into aerosols. So aerosols are droplets, which are very small of these acids, and they can also produce particles. So not only can there be deposition of those acid aerosols, which is sulfuric acid, or H2SO4, but also the sulfur salts or the sulfate salts, which can deposit on a certain medium and corrode it or impact it. They also reduce visibility, they also aggravate breathing problems, they also impact plants, they also impact monuments, statues, leather, clothes, stones, etc. And they are referred to as SOxes. Now, this image is of Taj Mahal. And the image on the right, where it's all yellow, is basically, actually, can someone from chemistry tell me what happened here? Nadia wants to speak, but I want Paul or Azhan to tell me what happened here before anyone else.
So, ma'am, I'm not 100% right now, so I'm just attending the lecture. I have a fever, so I'm not in a position to like comment.
Okay, Azhan, don't worry, don't worry.
Maybe
Okay.
Paul can answer this.
Or maybe I can, no, I shouldn't let Nadia answer this because she's already spoken. And then in the videos, when I watch it later, I see that I've only engaged a few people. So I will speak myself. So basically, Daniel has raised his hand. Thank you, Daniel. You can go ahead.
I'm not from chemistry, but from computer science. So what I understand is that the acid rain reacts with the marble of the Taj Mahal and it changes to this yellowish color.
Yeah. So basically, we just studied SOxes and NOxes. And what did we study in them? That when they go up in the atmosphere, they react with the water droplets, and the sulfur dioxide can convert into sulfuric acid, which is H2SO4. And the nitrogen dioxide or the nitric oxide can react with water and convert into nitric acid or nitrous acid, which is HNO3. And the acids, those who know chemistry, they would know that the acids are soluble in water. And that means that every time water decides to come down, then they would either be a part of the clouds, or whenever there's precipitation, they would come down onto Earth's surface. And when they do that, they can damage the plants, they can damage the stones, as we studied, their negative impacts. They can create several levels of damages, right? So there have been case studies that show that because of acid rain, and similar to what Nadia just said, so maybe a lake which was in a much more cleaner area got impacted because of acid rain, and the life in that lake died because the rain was too acidic. And something similar must have happened, that the acids were able to travel longer distances and precipitate elsewhere, resulting in the death of life that existed in that lake. Here, because it's marble, and marble is calcium carbonate, so it's CaCO3. And that CaCO3 reacts with these acids. And those acids then corrode the surface of it. And because they corroded the surface, the shiny surface of it, it started becoming yellow. So this was a problem, and it was an air pollution problem. And so this is like a depiction of what I just said, that your power plants, your aeroplanes, your cars, your motor vehicles, when they release nitric oxide or sulfur oxides and nitrogen oxides into the environment, and it becomes sulfuric acid, nitric acid, or nitrous acid, it can travel with the clouds and impact another place. Sometimes it can go somewhere and then because of surface runoff reach a certain area, or the acid can simply just deposit on a certain area. So whether that's dry deposition or wet deposition, in both cases, it's an air pollution problem, which is impacting the planet slightly away from its production point. And the next pollutant would be ozone. I think I already told you that it's colorless. It's highly reactive and it's colorless, and that's why you will not be able to see most of these pollutants. In Lahore, it's not that the nitrogen oxides or the sulfur oxides were not present in the air before, or maybe it's even carbon monoxide. It wasn't that the smoke didn't exist there before and the smoke in the form of these gases wasn't there before. Smog only helped us to see it because smog made it visible to us, right? And that's why I think sometimes I really feel that smog was a blessing in disguise, because it told people exactly what kind of air we're living in. So ozone's also a major ingredient of photochemical smog, a smog that is triggered by sunlight and all of these chemicals that we just spoke about. It also causes irritation of eyes, nose, throat, breathing problems, coughing, aggravates lung problems, aggravates heart problems, reduces your resistance to cold, damages plants, damages fabrics and paints, etc. And like I said, ozone in the troposphere is bad ozone, and ozone in the stratosphere is good ozone. Now, I think this is the last, if I'm not wrong, this is the last category of air pollutants that we'll be looking at. I said, Adine, you have a question.
Yes, ma'am. In one of the previous slides, you told us that ozone is like formed when oxygen reacts with UV rays, right? So this is a natural process. So how can we like control the production of ozone, because it is one of the pollutants in the in the environment? So how can we control its production?
Yeah, so that's also a good question. Basically, we don't need to create ozone on the troposphere and send it to the stratosphere. I don't think that is the idea. So there is ozone, plenty of ozone can be produced with the oxygen that exists in the stratosphere. And I might be wrong because research keeps on evolving. But because a lot of air, because of gravity and dense, yes?
So basically, it's a reversible reaction. So whenever the ozone is molecule is breaking, so it automatically, if we the human are not interfering with the natural process, so it will definitely form again.
Yeah, so that's what I'm saying, right? I'm saying that whatever happens has to happen in the stratosphere. So when oxygen molecule combines with another oxygen to form ozone, and when ozone breaks down again to oxygen molecule and an oxygen, it's continuously reversing. What happens when chlorofluorocarbon goes there is that it knocks it off and it reduces the number or the concentration of ozone in the stratosphere. But that doesn't mean that we can send ozone from troposphere to there, because in any case, the density of the gases often lies in the troposphere. So maybe we won't be able to send some of these gases there, and maybe we would be able to send some of these gases there. And because of gravity and general density, a lot of weight would be around the troposphere. And like Azan said, our responsibility is to make sure that we do not send things like chlorofluorocarbons into the stratosphere. So that's the only way that we can save it. Or for example, we can try and capture those back. We can try and clean them. We can try and bring those back and make sure that the air there remains free of such chemicals. So volatile organic compounds could be methane, but there are a huge range. I said that some plants even emit or release volatile organic compounds for defense. Methane is another gas which is released naturally as well. And it is 20 times more effective than a molecule of carbon dioxide at warming the planet. And that's why, although previous discussions were majorly focusing on carbon dioxide, a lot of the greenhouse gas discussion now focuses on methane. And that's why what Fateh mentioned and a few other things become important, that when you're farming, intensive farming of livestock could increase the release of methane. Open dump sites landfills that are not properly monitored, where methane is not captured, could increase the release of methane and therefore warming of the planet. And the methane can also be produced by natural and artificial resources. You always see with rice paddies, because we increase the level and then it doesn't allow carbon dioxide to escape, and mostly it escapes in the form of methane. So rice paddies are considered one of the biggest sources of methane and therefore contributors to greenhouse gas. And like I said, cows, the belching, the oil, natural gas wells, etc., also contribute to it as well. And then some other examples of volatile organic compounds are those that are released in the process of gasoline production or plastic production, or simple solvents that are used in chemistry lab like benzene, or even in households. They can also form vapors that just remain in the environment, but they are also pollutants, air pollutants. And now we come to particulates. And particulates are related directly to the discussion on smoke. So we call them suspended particulate matter because they can remain suspended in the air for a longer amount of time. And they can remain suspended because they might be very light in weight. And sometimes, and of course, they can be solid and liquid. And there are two categories, one's fine and the other's ultra fine. And you must have, if you were last year, if you had upgraded an app or installed an app into your phone for the smog levels, you must have looked at the 2.5 micrometer particulate matter readings. That's what the device device readings were related to. And these suspended particulate matters, again, I think because you've studied so much about smog, their impacts are more or less the same for all the other pollutants. But something that we forget when we talk about this, and we've mentioned it very often in this lecture, is the composition of the particulates. So if they're lead particulates, they impact you differently. If they're polychlorinated biphenyls, they impact your mental health differently. If it's a cadmium, it's a heavy metal, it would impact you differently. So I think that is something that we need to establish, but also to understand that particulate matters also have existed in the environment. We are only increasing or aggravating the levels of these into the atmosphere or into the troposphere. And that little increase creates so much havoc into the lives that we are living. And smoke could simply be divided into industrial smoke and photochemical smoke. And you know that in the discussion relating to ozone and nitrogen oxides, I said that they are photochemical smoke initiators, or they contribute to it. Industrial smoke simply is from the smoke that's coming from industries, which is also burning of fossil fuels, so coal, oil, natural gas, which you burn in the industries. And it would probably contain mixtures of sulfur dioxide, sulfuric acid, and other suspended particulate matters. And that smoke is called industrial smoke. And smog, you all already know that it's a combination of smoke and fog, right? So the fog particles combine with smog, and then they smoke, and then they turn into smog. In photochemical smog, these volatile organic compounds, the NOxes or the ozone or aldehydes or a few other secondary pollutants, in the presence of sunlight and heat, they can just trigger that kind of reaction where they react with one another and reduce visibility or create smog. And these are slightly different from each other because they're not just industrial smog anymore. They have multiple resources. And if you read a lot about Lahore last year, you would have seen that the major cause of the smog in Lahore was said to be vehicular emission. Vehicular emission was said to be the #1 source of smog in Lahore, followed by, I think, crop burning, and then a combined industrial smoke and the brick kilns smoke, which you can see in one of the images here. If you have a mind of a politician, you would also say that some of it was transboundary. And a lot of people said that the wind direction and the crop burning in India was actually also responsible for the high smog levels in Lahore. Hassan.
Yes. What was the primary contribution for? I haven't heard of that.
So the primary contributor was vehicular emission. So the emissions that's coming from our cars, which is why if you ask me, how should we reduce smog? I would say carpool, don't have individual cars, don't have that kind of lifestyle, because that was one of the major contributors to smog in Lahore. And that's why you could see an impact when schools were shut down, when the school buses and car and therefore a lot of transport was reduced. You could see a clear impact on the air of Lahore. Yes, Adeen.
Yes, ma'am. Can you please explain what aldehydes are?
So aldehydes are also volatile in nature, and they are basically used in a lot of household materials. They are used as insulators in the house. They're also used, I think, in wooden products. So if you have like compressed wooden products, they're chemicals that are part of it, but they are generally found in many household products. Yeah, so you must have read like terms like formaldehyde, acetaldehyde. So the general name for them would be aldehydes. Anything else?
No, ma'am. Thank you.
Okay, so so you must think that, oh, there's so much going on in the hydrosphere. So we studied the hydrosphere, we studied the biosphere, and we studied the atmosphere as well. But do you know how much have we studied? So like we've already studied very little, but if you could put all of this into weight of Earth, it will only be 0.05% of the total mass of Earth. So that's how tiny our fraction of environmental sciences has been so far. So Earth is way bigger and way complex than what we're looking at right now. And before I switch to the next session, I just wanted to touch upon indoor air pollution. And I think this is also something that we've established in the lectures as we've come this far, is the fact that most of us are now sitting in front of our computer, our screens indoors. And that's why the indoor air pollution is important. And right now, if I'm sitting here, then the air here is my air, right? Or the atmosphere here is my atmosphere. And because you live in a closed setting, this closed setting could increase the intensity of that pollutant. So no matter what the concentration is outside, that concentration could have greater impact on you inside the house, or that because in the air it just disperses, and that's why it can dilute itself. It's spread out quickly, whereas inside it would be difficult for it to spread as fast as it does in the atmosphere. And that's why I think the impact is higher. So whether someone's smoking in the house, whether they're cleaning solvents, whether there's incomplete burning, the concentrations would be higher, and therefore the impact would be higher. And whether you live a luxurious life of the one that's on the right, or you live in a very simple rural setting where you have an open stove, in both cases you're being impacted by the indoor air pollution. And I think you can just look at the slide in detail later. I did not pick it for any particular reason. It was just showing that how so many pollutants could be found in indoor environments, similar to the outdoor environments. And it's not just chemical pollutants, but also biological pollutants. So like I had said it sometimes, that because of air conditioning, if there's damp environment, more fungus and more bacteria could grow on your carpet, etc. as well. And generally, when people discuss climate, they always start with weather. And they say that weather is the short-term assessment of what's going on around you, and climate would be a long-term assessment of the same things. Long-term weather would be climate. I wanted to bring it at the end. And the reason I wanted to bring it at the end was because I also wanted to show you some images relating to weather monitoring. And I'm not sure where all the electrical engineers and physicists are hiding, because I was hoping that they would speak more in this course. So maybe in the section where I share some images, they can contribute. So weather essentially is a combination of all of these parameters. And why are these parameters important? Why do we care about solar radiations? Why do we care about the wind? Why do we care about how humid the air is? Why do we care about the pressure or the temperature? Because it helps us plan better. So for example, if I am trying to grow crop or if I am trying to harvest, if I look at the weather and the weather tells me that it's highly likely that it would rain in the next 2 days, I will not go there. If I'm going for a picnic and the weather tells me that it's super hot and humid in the coming days, I will cancel my plan. So those are the kind of decisions at a personal level, but at a huge country level, if you have to take decisions, then I think these become more important. And the solar radiations and their connection with, I think, the climate science and climate change becomes important. Because like I said, we are damaging the stratosphere to allow more heat to come in. And we are also creating more heat on the Earth's surface, and therefore we're warming the planet at a faster pace. And we're not able to deal with the consequences of the climate, which often comes in the form of a water disaster, whether that's a flood or whether that's a glacial lake outburst flood in the areas where there are glaciers, or whether it's a drought. You know, there can be multiple ways for it to show itself, to reveal itself to us. But it basically, and then in that case we could do better planning, right? So if the climate science tells us that in the next 5 years we're going to have dry period, then maybe we can plan for higher storage in this season of rain. If it tells us that it's going to be there are going to be wet seasons in the coming years, then maybe we can have more storage reservoirs, make sure that the areas don't flood. But also another thing that I think comes with climate and climate science and climate change is the unpredictability of it. It's not just about the change in weather pattern. It's not about the monsoons becoming intense and short. It's not about the summers becoming intense. It's not only about the winters becoming intense. It is also about the unpredictability, that you could have a completely hot day in one day of the summer and then maybe the coldest day in the next week. So that unpredictability of because sometimes even those predictions fail, because we, I think, have changed things so much that even those predictions at times have to just sit and watch what happens to the environment in reality. Someone raised their hands.
Yeah, ma'am. I just wanted to ask, ma'am, among these five things that directly affect the weather, what do you think is the most prominent thing that can affect the wildlife on the planet?
I think all of it. So the weather defines your overall environment, right? And one thing is related to the other. The atmospheric pressure and the wind are related, but they're also related to solar radiation. And that is also related to temperature. So it is all interlinked, and they're not separate from each other. I think they're one thing. They're just different ways to measure how our day-to-day life is changing.
Okay, ma'am, but I just wanted to ask one more thing that recently we got a news that a lion died. Lion or it was an elephant. It was died in Lahore Zoo, and they were like generally they were saying that um, the animal died due to a hot weather condition, so air temperature, I think. So is it good to say that the animal died due to it, or can there be any more reasons?
Yeah, I mean, obviously in that case it was what was the one drastic thing that changed from its natural habitat to this artificial habitat? So it depends on where did you bring that animal from in the wild. So let's say if it was an animal that you brought from Bahawalpur that could survive higher temperatures, then temperature won't be the most important thing in its survival. Maybe it would be able to adapt to it. But it also depends on the species. Remember when we discussed the biosphere, we said some species can adapt to the environment better, others cannot.
Yes.
We can do much better than many others, but some other animals are much better at coping with the changes in the environment than, for example, an amphibian is. So there's not one criteria. There's not a single criteria to say that. So if you bring a snow leopard from Hunza to Lahore, of course it would die on the way. It won't even make it. It possibly won't even make it to the to the sanctuary. But in any case, I mean, everything is important, and even that temperature is because of the solar radiation coming in, because of how much the earth is absorbing, because of how much it is reflecting or emitting. So I think it's all interlinked. But in that case, yes, definitely temperature.
Thank you.
All right, so the weather observation is done at the surfaces as well as with space. And the more I mention these things, I realize that maybe we should have one chapter on satellite or geographical information system in environmental applications, because it has come in our discussions again and again, and I haven't really planned a lecture on this. But anyways, you can use the satellites that are present in the, you remember where they are? Out of the 4 spheres of the atmosphere, they are in the thermosphere. So the satellites that are there are observing what's happening at the ground level, and also mostly in terms of radiations, how much is coming, how much is being reflected, how much is being absorbed, and also gases and isotopes. And those who understand chemistry more would maybe understand it better. But so that's one form of observation. Another form of observation is your surface observatories, where there's a practical weather station that's installed somewhere, and it tells you, what the concentration of a certain gas is in the air, or what the temperature of the air is. But in any case, there needs to be multiple sites, multiple data points for it to be compatible globally, because it's very variant. Right, Nadia?
Ma'am, what are these meteorological elements and how they determine the weather?
Yeah, so meteorological elements are the same thing, right? We studied about humidity, we studied about temperature, we studied about, like we mentioned them in the slides, the radiation or the heat or whatever you want to, however you want to put it. Those elements tell you what's going on, right? So the radiation or the temperature on the surface of Earth would tell you whether it's hot or cold. The humidity would tell you how humid it would be. Like hot and humid is worse than only hot. So they help you understand what the overall observation or feeling of the climate would be, not just for a human, but also for a plant and also for the glaciers. Okay. All right. So we will be, there's no particular reason to share this either, but I thought because you are studying it, you should know that there are various ways to measure temperature, pressure, wind, and you should know these terms. And wherever you go in your life, you'll find something or another. For example, if you go abroad, you'd always find this wind band somewhere, and it's essentially to tell you just the direction of the wind. And always look up and see which direction the rooster is, and it would tell you the direction of the wind. So in the olden times, these simple methods have also been used to tell what the direction of the wind is. So for example, that could also relate to a barbecue, that if you're doing a barbecue and the wind is in the opposite direction, then how do you set up a fire? So those basic decisions, and I'm not talking about major decisions, but generally, or if there is a fire in the city center, then this could tell you which direction the wind is going and where the smoke would eventually go to. And similarly to measure temperatures, you have both analog or digital devices. We had the analog ones in our house in the olden times, but now no one does that because we have iPhones and they tell us what the temperature is outside. The pressure is also measured by these devices. They could be more complicated. The barometric pressure could be with a simple Android barometer or with a barograph. It's up to how you want to calculate it or where in the world are you. So now the weather stations have evolved. Now it's becoming a simple gadget, and I think we have one, and I hope that I can invite, so Dr. Abubakar is not here today, but he is hopefully going to speak with you about a project that he's done with the HEC on Lahore's air pollution monitoring. And I will also ask him to touch upon weather stations because they've also built weather stations in the electric lab downstairs. So maybe that will give you a better real life understanding of it. So basically a weather station is a combination of all of those things. Something that can measure the pressure, something that can measure the temperature, something that can measure the precipitation rate. And I think someone asked me how to measure rain at home, or like how do you do it generally. I would say that that bird one is perhaps the simplest way to find out how much did it rain. And then that reading would be in centimeters, but you can just convert it into millimeters. But the devices have become more sophisticated, and now it's not even these devices, it's just sensors. And I think that's something that Dr. Bakr would definitely tell you. And I will share this lecture with him for him to know what I have not told you. And now we come to a home task, and I think we're going to have some time for class discussion. So your home task for next week is raise your hands if you watch the news and if you watch the weather forecast sometimes. All right. And also raise your hands if for the longest amount of time you did not understand what they were saying, like except for it's going to rain or it's going to be sunny. Because I did not know it. I'm guilty of not knowing what the lines meant. And I'm guilty of not knowing what the distance between the line is and what those arrows meant. I'm guilty of all of those. And it's only when I started doing my undergrad, although I had looked at the weather forecast throughout, did I realize that I need to know exactly what it is. And so my home task, like the only thing that I can perhaps teach you is to be able to learn what a weather report actually means. And there are a few slides that I've put. I would have loved to explain it, but I'm not explaining it. Some people would be able to interpret the graphs better, but this is just a weather reports video. And basically with these graphs should help you in understanding what they actually mean when they say it's going this way or that way, or what do the circles mean, or what do the lines or the isobars mean. But if you think it would be difficult for you, I have just pasted 2 links from YouTube, one's from BBC and I think one's from Met Office in the UK as well, because that's where you care the more for weather. It's sunny 1 minute and it rains the next minute. So they've explained how to interpret those. So if it's difficult for you to do that with the help of the pictures or the graphs, maybe you can just use those videos and understand it. And climate change monitoring, I totally forgot that I put it here. So climate change monitoring is, again, like I said, weather is short-term changes in the temperature, in the air, in the humidity, in the heat, or whatever you call it. But climate change is long-term. It's over a longer period of time. And you can look at it in several ways. You can look at the solar activity. So for example, how much heat is being radiated, how much heat is being absorbed, emitted, etc. You can also look at other natural processes, like you can monitor a particular volcanic eruption, because that's where a lot of soot and chemicals are also released into the environment. You can use that, or you can just check certain isotopes, certain elements, certain chemicals, or simply water vapors. Just monitor them to see what's happening in the atmosphere or on the surface of Earth. But I think we've mentioned this before, that biomass or vegetation or the green color or cover is also often done or monitored through these satellites that are present in the atmosphere. And I think what I want you to do, or what I want you to be able to do, is at least go back and look at some of those climate change graphs or some of these maps that they show you, and just try to interpret it. You don't have to be 100% correct at it. I'm not, like, I've indirectly taught you climate change or climate science a little bit, but because we have a guest lecture later with someone who's doing climate change, transboundary climate change using Kabul River Basin, and he's looking at its impact on agriculture, upstream, downstream, etc. So I'll also ask him to explain the same concepts there, and also like help you understand how to interpret data in climate science, especially graphs like these. And for example, here, if I'm just saying that it's an atmospheric oceanic interaction, then it could be that how much heat is coming. So it's telling you where, like, what the temperature is at the surface of that hydrosphere. And they can plug each other, right? If the sunlight is high, and more evaporation happens and clouds are formed, then those clouds can stop more sunlight to come in and therefore reduce the temperature. It could also be that at some point down there where it's red or yellow, a human industry is throwing warm water into it. So that there can be a lot of explanations, but for that you not only need this data. So the reason to share this was that I don't have any data for what's going on the ground. So right now I can only see that over a certain period, the temperature ranges so heavily, but I don't have any data from the land. So unless I have a picture of what's happening there, I can only just say that the temperature is variant. And so we may not be able to find kind of life that lives in cooler temperatures in the areas where the temperature is high. So let's say if I'm looking for a certain fish, I would not be able to find it in the areas where it's red or yellow. But I cannot know more. So that's why the space-based observation and the ground-based observations often need to complement each other. They can be as simple as just a photographic image of that area where the reflection is red. Right, and the control, I will explain it, but I don't want you to get scared of this. But those who are doing chemistry, and certainly those who want to work towards pollution remediation should worry about it. So how do you control these things? You try and make sure that you plant more trees, you want a good regulatory body, you want good laws, you want good individual actions, good implementation or enforcement of the laws, you want the water quality to be improved, you want the biosphere or the wildlife to be in action. But if you talk about hardcore control or hardcore measures to make sure that the emissions are clean, or they're not polluted, they don't contain all of those pollutants that we just read about, you can use these scrubbers or these electrostatic precipitators. And I have an image that shows you, oh, where did the other image go? Yeah, so this is like the image before an electrostatic precipitator was put on the chimneys. And right after the electrostatic precipitator was put on the chimneys, that's the emission. So I think you need to just know that how much can be done just at the source instead of polluting the atmosphere so recklessly. Yeah, so I have put a link which tells you what the ambient air quality standards are. And I've also put a term there. Again, you don't have to know the science behind it. I found a paper, but it wasn't a great paper. It was about Lahore being an urban heat island. But I just want you to quickly Google it and know what an urban heat island is. And I think I am done for today. So I will try and redirect to the chat. People who have questions, people who have comments, please go ahead. Yeah, no questions? So we only have 2 minutes and I can maybe take a few comments. No questions. Azhan has no questions. Okay. That's great. People have seen weather stations or in real life. That's great. Okay. Yeah, the air quality improved a lot during the lockdown, but I think something that I forgot to mention was that the ozone levels at the troposphere had actually increased. I don't know what the reasons for that were, but there were a lot of international articles coming out that were saying that even though the ozone in the stratosphere is healing, the ozone concentration on the troposphere is also increasing. So like those instant impacts may not have changed the overall climate that much. And yeah, so your cities were much cleaner in the lockdown. All right, if you have no questions, then I think we are done for the lecture today. And if I'm not wrong, someone is, like, a couple of people are missing in this class as well, which is not a good sign, because no one sent me any email saying we will not be attending the class. And thank you. This is it from me.
Allah Hafiz, ma'am.
Allah Hafiz.
Allah Hafiz, ma'am.
Allah Hafiz, everyone.
Excuse me, ma'am.
Yes.
I just I just wanted to ask whether should I email you or there is an LMS type for the submission of written CVs.
Who's
I
that?
recently joined the class. Hamza,
Oh,
Mohammed Hamza.
okay, Hamza, you can email me the tasks. You can email me the tasks. So I will, if you send me the task, that means that I am ready to mark everybody else. So I'm just
Okay,
waiting.
okay. I'll just send it to you in a few minutes. Okay.
Okay, cool. Okay, super. Thank you. Okay, Summer. So I think I await the attendance sheet from you now. Because if I have a look at the attendance, then if wherever you're confused or wherever you couldn't look at it carefully, just let me know. Let me pause.